Hello students, standard 6. In the chapter number 10, mensuration, we learn about the perimeter of different type of closed figures. Some are regular shape, some are other different shapes. We know that the length of the boundary is known as the perimeter of that closed figure. For some regular polygons, we find formulas also, like for the rectangle or equilateral triangle, pentagon, regular hexagon, etc. We also have the perimeter for a rectangle. And for the circle, it is the circumference which is known as its perimeter. Now, we are going to learn about the area. What actually the area is. We are familiar with so many closed figures, like circle or a square, a rectangle, a triangle. But there are some irregular shapes also. For example, the leaves of the tree, they don't have a definite shape. A star, a piece of paper which is cut unevenly, like shown in this figure here. You can see that there are different types of figures are given here. Now, that figure, all this closed figure, occupy some space on that plane. So, the surface, the amount of surface enclosed by a closed figure is called its area. It means that suppose this is a closed figure. So that part is enclosed by this figure. So the amount of that surface which is enclosed by that closed figure is called its area. Suppose this is our board. So this part, whole thing inside, if you find the measure of that place, that surface, is known as the area of that board. Similarly, if I put a paper here and draw the rectangle, then that surface which is occupying that surface, the amount of that is known as the area of that object. Now, as I show you that different figures, can you guess that whose area will be more and whose area will be less? Sometimes you can, when there is a very big figure, other is very small, then you can easily tell that whose area will be more and area of which figure will be smaller. But if they are having similar spaces, similar sizes, maybe a minor difference between them, then only by looking at them can you tell which figure has a larger area and which figure has smaller area. Actually, it is very difficult in this situation that area of which figure is more and area of which figure is less. And then there is an idea in which we have to use a squared paper or a graph paper. You have to, like this, I draw. The squared paper are also available, or betterly you can use a graph paper. So to estimate the area of closed figures, place them on a graph paper and make an outline of the figure with the pencil. So what we have to do, we have to take a squared paper or a graph paper and put that object on that graph paper and draw that outlines of that object with the pencil and take the object back. So now you have to observe the squares which are enclosed within that figure. And then also you will see that, you will observe that some squares will be completely enclosed within that figure. Some squares are very smaller, means less than the half squares also are enclosed. Some exactly half square will be enclosed, and some will be more than half squares. So now in this situation, what we have to do, how can we find out the estimated area of that figure? So in this situation, we can follow a rule that will be helping us to find out the nearest estimated area of that figure. And so we can compare them. In this situation, what will we do? That within that enclosed figure, first count the squares in 4 categories. Full enclosed means the total whole square is enclosed within that figure. Count the number of that. Then count those who are enclosed more than a half. Then count exactly half squares which are enclosed. And then at last, those squares who are less than half are enclosed. And then what we have to do, such that you can see here, the area of one full square is taken as 1 square unit. It means that the whole squares are enclosed. The area of that one, each square is taken as 1 square unit. If that square are of 1 centimeter length, you can say it is 1 square centimeter. So first find the fully enclosed squares, and then write down that total amount of that squares. Then ignore portions of the area that are less than half a square. Means those squares which are enclosed but they are less than half, then we have to neglect them. We have to ignore that portions of the area. Then third, if more than half of a square is in a region, that also count as a full square. Because only a little part is gone, that can be adjusted with those who are less than half. So that can nearly balance that whatever is that. So in this situation, more than half squares are also counted as the full squares. And then exactly half square. If exactly half the square is counted, then take its area as 1 by 2 square units. How much? 1 upon 2 half. Because they are exactly half. And then we have to make the total of that. And that will give you the estimated area of that closed figure. Here I tried to explain you with an example that a irregular shaped object is there. I try to make the squares. Now I put that object and take the boundary, mark the boundary with the pencil. Now we have to first find the full square. So there are 7 full squares. 1, 2, 3, 4, 5, 6 and 7. So 7 full squares, so I write down full square 7. So its area is 7 square units. Then half squares. You can see that 1 and 2, they are half squares. So half squares are 2. So its area is 2 multiplied by 1 by 2. 2 multiplied by 1 by 2. That will be different square units. Finally, we will find the total square units. Now, then I take more than half. More than half, I got 4. Like 1 here, 2 here, 3 here, and a 4 here. So 4 are more than half. And then less than half, there are another 4. Very smaller part is not there. So we cannot take that part. So that we have to ignore that. Now we have to make the total of this. So here 4 are 7. Then other more than half are 4. So 7 plus 4, 11. Now 2 into half, 11, it will be cancelled. So 1. 7 plus 4, 11. 11 plus 1, 12. So 12 square units is the area. Approximate 12 square units area. So by this way, you can find out the amount, the estimated area of any figure. It can be a square, you can take any other objects, then you put it there, draw the boundary, take it up, first count the full squares, half squares, more than half squares, less than half squares. And then you make the total and then you will find the estimated area of that figure. Now, as we already saw how to estimate the area of closed figure by using graph paper or squared paper. So on the basis of that, exercise 10.12 is given. Now, in which the different figures are already shown on the graph paper or the squared paper. So, as I showed in the example that you have to find the full square, half squares, more than half and less than half. And according to this table that's made here, you can see that. According to that, you also have to make the table for each and you can find out the area on your own. So I am giving you exercise 10.2 as homework. It is very, very simple. Just count the full squares and more than half square. They are counted as full squares. So that will you have to count. Exactly half, then you have to multiply by 1 by 2. And less than half, you have to ignore. And then make the total that will give you the estimated area of that each figure. So it is very simple. You can do that. For that you can use one thing also. First what you do, put full tick mark. For example, I will tell you. First all full squares inside you put tick marks first. Full squares and more than half squares. You put tick marks. And then exactly half square, you can make another sign like dot inside. Then you can count that one also. And then in less than half, you can make cross. So that you have to ignore. And then count whatever are there according to that example. Then you will be able to find that. Now, every time we cannot use these formulas. You know why? Because if you have to find the area of the land which is in the square or which is in the rectangle form, you cannot take that much big graph paper to draw that land. So it is inconvenient. It is only applicable for the small objects which can be drawn on the graph paper. So when there are big things like clothes or the cupboards or your floor, you have to find the area of the floor. Is it possible with the graph paper? Not. So in this situation we need some method that without graph paper we have to find that area. In this situation we have to find some special formulas, particular method to find out the area. So those big like doors and windows, everything, cupboards, wall. So in this situation let us understand first about the area of a rectangle. First I will explain you with the help of a small rectangle on the graph paper, and from that we will find a general formula that can be applicable for all the rectangles. Here I draw a squared paper in which I took a rectangle. So draw that rectangle. Now you can see that 1, 2, 3, 4, 5, 6, 7 and 8. Total 8 complete squares are enclosed in it. No half squares, no more than half, no less than half. In this situation, 1, 2, 3, 4, 5, 6, 7, 8. It means that area of this rectangle is 8 square units. So here you can see that 4 and 4, 2 times are there. So you can write down as 4 multiplied by 2 square centimeter. 4 multiplied by 2. You can see that 4 is the length and 2 is the breadth. So you can write down as length multiplied by breadth. So by this method we can find the area. Formula for the area, that is area of a rectangle is equal to length multiplied by breadth. So here we don't need square paper now. We don't need a graph paper now, because from the graph paper we already understand that whenever there is a rectangle, completely enclosed squares will be there, and therefore the area will be in complete square units, and that is the multiplication of its length and its breadth. So whenever you see a rectangle, you need two measurements, the length of it and the breadth of it. For example, if you want to find the area of this page, first find the length, find the breadth, and then multiply. So we get the area here. We wrote down the formula. Area of a rectangle is equal to length multiplied by breadth. So that will be very useful in your future also. So please keep this formulas in your mind. So area of a rectangle is length multiplied by breadth. The bigger is called the length, smaller is called the breadth. Right? So length multiplied by breadth. Similarly, square. When you have the square like this, here you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 squares are enclosed. So its area is 9 square centimeter. But 9 can be written as 3 into 3 because 3 in the row, 3 in the column. That is the side. It means it is side multiplied by side, or length multiplied by length. So we get another formula for the square. That was rectangle. Now we get the other formula, that is for the square. Area of a square is equal to side multiplied by side, or you can write down as length multiplied by length. So today we will learn two formulas. That formula you have to keep in the mind. It can be asked in the MCQs also, and it will be useful to find the area of the field, area of the door, windows, that is in the form of rectangle or square. So area of rectangle is length multiplied by breadth, and area of square is side multiplied by side or length multiplied by length. So here we are going to finish the video, and already homework is given 10.2, so I am not going to give you more homework, but that all you have to write down in your notebook. Thank you very much.